What up, LH2? Hopefully everything's going well. Last and final installment here before we are taking our test next week. So we're going to talk about the quadratic formula here. We've talked about three different ways so far to solve a quadratic equation. One, if it's just x squared, you solve by undoing, taking the square roots. Make sure there's a plus and a minus when you take the square root. And then we did solve by factoring. Took it, did our little cheater method, got the two factors, took each factor, set it equal to 0, and solved. And then we did completing the square, which was a little bit of both, where we took the b term, divided by 2, squared it, added that number to both sides. The reason why we call it completing the square is now what was left on the left side, we could factor it and then take the square root. So it was kind of doing undoing and factoring together. And then today we are doing the quadratic formula. So first off, as a quick little warm-up, taking square roots, simplifying them down if we need to. Square root of negative 49, well, that's a non-real number, right? Hint, hint, moving forward, foreshadowing. We're going to have to take out, that's just going to be 7 and then I. Again, we would take square root of 49. Those of you like unsure of I still, we would take this as square root of negative 1 times the square root of 49. Square root of negative 1 is equal to I. Square root of 49 is 7, so then we would write it as 7I. All right. If it's not a perfect square, we would look to break it down into perfect square factors. So square root of 25 times the square root of 3, so that's 5 radical 3. And then our last but not least, negative 54 is going to give us, we could do 9 and 6. Is that going to work out? Oh, maybe. So, and it's going to be I. So we're going to do square root of 9 times the square root of 6. That's going to be 3 times the square root of 6. 6 can't be broken down anymore, except for 2 and 3. So we're going to bring this 5 down. 5 times 3 is 15. And then we had the negative under the radical sign, so that's going to give us an I times radical 6. All right, and the reason why we're doing this is we're going to have to simplify fractions down today. One other thing I want to show, some may have called this the butterfly method back in the day. Let's say it was something like this, and we wanted to simplify this fraction. Well, what we would do is we would look to see if there's a common factor out of these two numbers. If there was, it better be the same common factor out of those two numbers. And thankfully, they're all divisible by 3. If all 3 are divisible by the same number, then we can simplify it down and say that's x plus 3 over 4. All right, there's a reason why we're going to show you this here in a second, but just wanted to show you that. All right, here is the quadratic formula when we are in standard form. Ax squared plus bx plus c. The quadratic formula is the opposite of the b value, plus or minus, because again we would take the square root, so that was where the positive and the negative come from. B squared minus 4ac all over 2a. So with this one, all we need to do is identify a, b, and c and substitute them into the formula in their respective spots and then do our math. I'm getting my calculator on my phone handy for the math. You should probably be doing the same. All right, first is the discriminant. This is the number under the radical sign, right? That discriminant tells us a couple things about our solutions. One, it tells us how many. And if we think of our graphs, we either have 2 solutions where it crosses the x-axis. We have one solution where the vertex is right on the x-axis, or we have no solution where the vertex or the graph does not cross the x-axis at all. So we either have 0, 1, or 2 solutions, all right? And as we found out at the beginning of this unit, if we're taking square roots of negative numbers, we have real solutions and non-real solutions. So this guy right here has 0 real solutions, but we'll have 2 negative solutions. And we're going to do that by simplifying a negative square root with I and then reducing the fraction down at the end. So when we are talking the discriminant, this number under the radical sign, it's either positive or negative. If it's positive, it has 2 real. If it's negative, it has 2 non-real. If it's equal to 0, well, then that just goes away, and there's one solution, negative b over 2a. So that's that. And this is exactly what we just talked about. Okay, so the discriminant's the number under the square root symbol, the b squared minus 4ac. If it's a positive number, if it's greater than 0, it has 2 real solutions. If it's 0, right, if b squared minus 4ac equals 0, then it has 1 real solution, a repeated real, so 1 real. If it's negative, then we have no solutions, no real solutions, or we have 2 imaginary solutions. I think I spelled that right. Okay, so if the discriminant's negative, we have 0 real solutions, but we'll have 2 non-real or 2 imaginary solutions. All right, here we go. Solve this, and again, I would always look, if I had to choose a method, right, I would try to factor it. Factors of 14 that add to get negative 8. You're not going to get one. Negative 7 and negative 2 get you negative 9. So if we are going to do this, we're going to do a equals, b equals, and c equals. Oh, this is just saying what's the value of the discriminant. So we need b squared minus 4ac only. That's cool. All right, a is 1, b is negative 8, and c is 14. Substitute those values in. Negative 8 squared minus 4 times 1 times a little 14. That's 64 minus a 56. That number is positive. So the discriminant is 64 minus 56, which gives a grand total of 8. So the discriminant is 8. Number of solutions, 2. Type of solutions, they're real versus complex or imaginary. And now we got to find out what they are. So now we're going to do the quadratic formula. Okay, so we're going to do opposite of b value. So opposite of negative 8, which is positive 8, plus or minus square root of that discriminant, which we've just found was 8. So b squared minus 4ac, that gave us 8 under the radical. But I'll write it in just so you could see. I would like for you to show me substituting the values in and not just coming up with a solution, just so we could check to make sure if you're getting the wrong answer. What the heck's going on? All over 2a, so 2 times 1, right? And this is where we're going to simplify. Negative times a negative is a positive 8. And then we already found the discriminant was 56. Sorry, not 56, it was 8. All over 2a. Okay, so that's where we're at. And then we want to take and try to simplify this down. So you got 2 things. One, you have to try to break down the radical, square root of 8. Can simplify into the square root of 4 times the square root of 2, so that's 2 radical 2. So then we have 8 plus or minus 2 radical 2 all over 2. And then we were talking about, hey, what happens if this part and this part have common factor? And they do. 8 and 2 are divisible by 2. 2 radical 2 and 2 are divisible by 2. So I'm going to simplify this down by dividing each of these parts by 2. So since it's all over 1, I don't need to write it. It's going to be 4 plus or minus the square root of 2. So my solutions would be 4 plus square root of 2 and 4 minus square root of 2. These are exact values. If we wanted approximations, which I think will be a little bit more handy to us, if I had to plot these numbers on a number line, you would do the square root of 2. You would do 4 plus the square root of 2. And that gives you about 5.414. And then we would do 4 minus the square root of 2, which gives us about 2.586 if we were going to approximate. Okay, so the difference between exact and approximations. All right, just plugging the numbers in the calculator. So we're going to actually ask you to do both on the test next week. This is what one of the questions will look like. Here you go. Solve using the quadratic formula. What's the discriminant? How many solutions? What are the type of solutions? Exact answers and approximate answers. So hopefully you're watching the video and paying attention, because now you know one of the questions on the test. All right. So here we go. Next question. We are going to find out the value of the discriminant first. So we got to find out A, B, and C. A is -3, B is 6, and C, ooh, that's not really a number yet. We want to add 5 to both sides. We want to get it in standard form first. So we want one side equal to 0, so that's going to be a +5. So make sure we get everything on one side before we start labeling A, B, and C. Sometimes I get ahead of myself. Okay. All right, let's find the value of the discriminant. B squared minus 4AC. So B is 6 squared minus 4 times -3 times 5. Well, that's going to give us a nice positive number, because 4 times 3 is 12. And those are both negatives. 12 times 5 gives us a grand total of 60. So we have 64 plus 60, which is 124. So this is going to be number of solutions. 2 real. Better find them out. Okay, so quadratic formula then would be -b, so -6 plus or minus the square root of all that business, all over 2 times the A value. All right, now let's do our math. -6 plus or minus the square root of 124 divided by -6. And then now we got to look to break down our square roots. This is going to be 124. Breaks down into 4 times 31. 31 is a nice ugly number. So then this is going to equal -6 plus or minus 2 times the square root of 31 all over -6. And then divide 2 or -2, depending on how you want to look at it. It's not going to do any difference. Divide 2 out of everything, because they're all divisible by 2. So divide by 2, that's 3. Divide by 2, that's 1. Divide by 2, that's 3. So our solutions would be -3 plus the square root of 31 over -3. And then we write that there. And the other solution would be -3 minus the square root of 31, all divided by -3. So break them apart into 2 answers. Okay, those are the exact answers. If I wanted to approximate this, I would type it in the calculator. I don't know how you guys use your phone for a calculator. This is super annoying. -3 plus 31 square root is 2.568-ish. And then -3 minus the square root of 31. Oh, shoot, I think I forgot to divide the first one by -3. I'm going to go back and fix that. So this is 2.856. I'm going to go do the math again, plus the square root of 31. Yep, divided by -3. Forgot to do that for this first one. So my approximate solution would be -0.856. All right. I'll do one more, and then you can try the next 3 out on your own, and then I will go over them for you. Okay? All right, first things first, let's get everything on one side. So 2x squared minus 7x minus 6 equals 0. Okay, a is 2, b is negative 7, c is negative 6. Let's find the discriminant. That's the b squared minus 4ac part. So we're going to go negative 7 squared minus 4 times 2 times negative 6. Again, this is going to be a positive number because we got a negative here and a negative here. So that's going to turn it into an adding sign. So we got 49 and then 24 times 2 is 64. And then 49 plus 64 looks like it's 113. Again, 2 real. And then we have to go through and find out those solutions. Well, the rest of the quadratic formula would be opposite of the b value plus or minus the square root of all that mess all over 2a. So we got 7 plus or minus the square root of 113 all over 4. 113, man, I don't know. Don't think we're going to get too many numbers dividing into 113. That might actually be a prime number. Ain't going to lie. Try 7, last number. Yep, so that's prime. We're not going to be able to simplify this down, so our two solutions would be 7 plus square root of 113 over 4, and 7 minus the square root of 113 over 4. Yeah, I tried all the weird ones. Don't have to go much past 11 because the square root of 11 is 121. Or sorry, 11 squared is 121, so the square root of 113 is in between 10 and 11, so that's that. And then you can approximate those. I'm looking at example 4 because I want to do a negative one quick. Yep, this one looks like it's going to be a negative value for the discriminant. When I rearrange everything, make sure it's in proper form, we got 3x squared plus 4x plus 8 equals 0. All right, a is 3, b is 4, c is 8. So when I do b squared minus 4ac, I got 4 squared minus 4 times 3 times 8. Right, and then 16 minus 96 is what that ends up being, which gives us negative 80. So the value of the discriminant is negative. Number of solutions, 2 non-real, 2 imaginary, 2 complex would be the words to use. We could say there are 0 real solutions, right? So what does that mean? That means when we do the quadratic formula here, we're going to have I as a part of our answer. That's all that means. So we got negative b plus or minus the square root, b squared, all over 2a. And well, then we got negative 4 plus or minus the square root of negative 80 all over 6. I know 80 is divisible by 4, but is it divisible by 16 as well? Yep. So we're going to break down 80 into 16 and 5. So 80 is going to be 4 times the square root of 5. So we have negative 4 plus or minus 4i. The I is coming from the square root of the negative piece there. Radical 5 all over 6. And then we have time to simplify. Everything is divisible by 2. So divide by 2, divide by 2, and divide by 2. So we have negative 2 plus or minus 2i radical 5 over 3. And those would be our two solutions. Negative 2 plus 2i radical 5 over 3, and negative 2 minus 2i radical 5 over 3. All right, so that is that. If you ever get confused about what the types of solutions and everything are, you can find that. Just scroll up. If the discriminant's bigger than 0, 2 real solutions. Equal to 0, 1 real solution. And then if it's negative, we have no real solutions, but we have 2 imaginary. We can write the word 2 complex, or 2 non-real. I would accept any of those 3 words. So good luck. Again, be ready for our test. Friday, we are going to be doing a standard checking class. So yay us. This is the last of the new material. So if you're plugging along, scooting along, then you are good to go.